Good morning. So we have now our new topic, two-dimensional array. So in two-dimensional array, in this new topic, we're going to discuss what a two-dimensional array is, what are the different operations for two-dimensional array, and the address calculations for this kind of array. So when we say two-dimensional array, definitely it is an array having two subscripts. Remember, the dimensionality of the array will be determined by the number of subscripts. Okay, so in this case, we have two subscripts for two-dimensional array. We have subscript 1 and subscript 2. Okay, wherein the size of subscript 1 as well as the size of the subscript 2 would be it could be 1 or more up to m value, and for subscript 2 from 1 to n value. Okay, so as an example, we have here an array named R of size m by n. Okay, when we say m, that is the number of rows, and n is the number of columns. Okay, so remember that the first value we are pertaining to the row, and the second value we are pertaining to the column. Okay, there are some programming languages that they use the other way around. The first value or the first variable pertains to the number of columns, while the second variable pertains to the number of rows. However, in general po, no, the first variable would determine the number of rows, and the second variable would determine the number of columns. Now, since our subject is data structures and algorithm, definitely we will make use of the generally used by all programming language, or by most of the programming languages. Okay, so as an example, we have an array named R of size 2 by 3. That means we have an array named R having 2 rows with 3 columns. Okay, so we have here as a representation, okay, we have an array named R having 2 rows. So this is 1 row and another row. Okay, and then sabi niya, it has 3 columns. So we have 1, 2, and 3. Okay, so we have here an example having 6 elements: Annabelle, Laura, Dang, Emily, Rolette, and Che. Now, for each element, it is stored in a row and a column. So, the intersection of the row and the column, that pertains to the element of an array, of a two-dimensional array. Now, we have to refer to that element using the row number and the column number. So, as you have noticed, we have here Annabelle. Annabelle is stored at row 1, first row, okay, row 1, column 1. That's why we have here the index 1, 1, or sub 1, sub 1. And then the next element is Laura, that is stored at row 1, same row, but different column. So column 2. So Elora is stored at row 1, column 2. And then the next element is stored at row 1, column 3. We are pertaining to the element Dang. And then after this row, the following row, we have row 2. So as you have noticed, the first value we pertain to the row number. Okay, so this is row 2. That's why it is 2. And then the values for each element in the row, in row 2, okay, we have to determine what column. So at row 2, column 1, we pertain to Emmeline. And then at row 2, column 2, we pertain to Roulette. And at row 2, same row, but column 3, we are pertaining to Che. Okay, so we have here 2 rows. So we have 1, 2, and then we have 3 columns, 1, 2, and 3. Okay, so again, row 1 is 1, everything that is written in this first row. Okay? So we have that index 1. Okay? So we have 1, row 1, row 1, row 1. Okay? And then, for the next row, we are pertaining to row 2. Okay? So row 2, row 2. Okay? And then next, we will now have the columns. Okay? So, Annabelle is stored at the first column. So, row 1, column 1. Okay? So, at row 1, column 1, Annabelle. So, the intersection of the row and the column. Okay? So, that is our index. Okay? So, at row 1, column 2, we pertain to Elora. Row 1, column 3, we pertain to Dang. Okay? Moving on, at row 2, but first column, so we have 2, 1, we refer to element Emeline. And then, same row, but on the second column, so 2, 2, we pertain to Roulette. And then, at the last column, at row 2, column 3, we pertain to Check. Okay? So, this is the values. Okay, so same with one-dimensional array, we have different operations for two-dimensional array. Now, for our class, we will just discuss the 5 operations for two-dimensional array. Okay, so first operation is storing a new value into the ith position such that the I is whose values is from 1 to m. So that means from 1 up to the size of the row. Okay, and or the number of rows of the array. And then while the j, we are pertaining to values from 1 to n. Okay, 1 to n, where our n is the number of columns. Okay, so after that, we also have another operation that is retrieving. Again, retrieving the ith elements in the array. Same with the previous one, wherein I is the row number and j is the column number. And then next operation is reading all the elements in the array, either using column-wise or column major, or row-wise, or what we call row major. Okay, later we will have a deeper explanation on that. Okay, and then fourth operation, we have deleting an element at the ith position. So we want to delete an element, we have to specify the position. But since this is a two-dimensional array, definitely we have to specify the row number and the column number. And then lastly, our last operation is the copying an array, either row-wise or column-wise. Okay? So, if we're going to store a new value into the ith position, so we must specify the row position and the column position of that element. For example, we want to store Lali. So Lali is a constant string. Okay? We want to store Lali at the second row, third column. So in order to do that, we have to make use of an assignment statement wherein the constant string Lali is placed on the right side of the assignment statement. Okay, so while on the left side we have to define, okay, what is the array name, since we have from our previous example, our array is named R, so we will just be consistent with our array name. So we have R, and then since we want to store Lali at second row, that's why the first index pertains to the row number. So we have 2. And then at the third column, so it pertains to the second subscript that pertains to the third column, or the column position. Okay? So in this case, if we want to store, or we could now store lali, a constant string lali, to r sub 2 sub 3. Okay? So r sub 2 sub 3, that means we're going to store lali, element lali at array r, array named r, at row 2, column 3. Alright, based on our previous example, if we want to store lali, okay, we want to store lali. Since this is a constant string, we have to enclose that with quotation marks, okay? We want to store lali where at row 2, column 3 of our array named R. Okay? So R2 sub or R sub 2 sub 3, we're going to store lali. So that means if we have this array, okay, and we want to store lali at row 2, so that pertains to this row, okay? Row 2, column 3. Okay, so row 2, column 3. So we pertain to check. So in this case, we pertain to check, okay? And we want to store lali at row 2, column 3. So what will happen to check? Very good. Che will be replaced by lali. So instead of che, that will now be lali. Just like our one-dimensional array, okay? And the next, we have now retrieving the ith element in the array such that the value of the I is from 1 to m, from 1 to the size of the row of the array, and then while the j is the size, its size will be from 1 the to the n, or the number of columns of the array. Okay, so simply, if you want to retrieve the ij position, simply specify the array name and the two subscript, okay, of the desired element. Example, we want to retrieve the element at the element at row 2, column 3. Okay. So if you want to retrieve this, just specify the name of the array and the row position, the column position. Now, if you want to display the value of um, that element, you simply execute print and then the name of the array and the row and specify the index by specifying the row number and the column position. The row position, the column position. Okay? So what will happen? So we have now to bear in mind whenever we have this kind of arrays, no? The dimensionality of the array would also determine the number of loops that we need for that kind of array. So if we have two-dimensional array, definitely we're going to make use of two loops. While if we have three-dimensional array, that would require three loops. Okay? Also remember, we have two kinds of operation with two-dimensional array. Either we could use row major or we could use column major. Now, what's the difference between the two? When we make use of row major or row wise, that means we're going to process all the elements by row. So first row will be processed first, followed by the second row and all columns, and then followed by the nth row. Okay? Well, if we have column major, the priority will be on the column. Okay? So all elements on the first column, regardless of the number of rows, for as long as it is in the first column, that will be processed first. And then after that, it will process the next column, row 1, row 2, row 3, and then the next column, row 1, row 2, row 3, or up to row n. Okay? So, let's have an example. Okay? if we want to copy elements of the array using row-wise or row major, now row, we pertain to the ith and jth position, okay? Now, as you can see, in our parameter, initially, okay, we have copy to dime, the name of the pseudocode, and then we have the array name R having its sizes m by n. So let's have m by n. So if we have 3 and 2, that means we have 3 rows and 2 columns. Okay? So when we refer to row major, that means we're going to prioritize the row, okay, followed by the first row, and then followed by the next row. Let's have an example. Let us say in our case, no, we have there three rows, and 2 columns. Okay, so the name of the arrays are having 3 rows, so 1, 2, 2, and 3. So we have 3 rows, 3, okay, and 2 columns, 1, 2, 2 columns, okay. Now, if you want to copy the elements, okay, when we copy elements, definitely just like our copying of elements in one-dimensional array, the same rule follows. Okay, we should have the same size of the array. So we should have another array. So we call it B. Okay, wherein the size of the array B is the same size of the array R. So if array R has 3 rows, so array B should have 3 rows. If array R has 2 columns, so definitely we will also have 2 columns for array B. Okay? Now, the elements of this one, okay, the elements of the elements of this one, row 1, column 1 of B, okay, the value of row 1, column 1 of B should be the element at row 1, column 1 of R, okay? Okay, let's have values rather for our array R. So let us say we have A, B, C, D, E, and F. Okay? Now, if we have row major, okay, the idea would be we're going to read or we're going to process all elements by row. So we will process first A, B, C, then followed by the second row, C, D, and the third row, E, F. Okay? So, A will be assigned, okay, to row 1, column 1. Okay? And then B will be assigned to row 1, column 2. Okay? B is row 1, column 2, so same row 1, column 2. We'll have B. While C will be assigned to row, what row? C is at row 2, column 1, so row 2, column 1. Okay? And then we have D will be assigned to, okay, so this is a constant string, so we have to enclose with single quote. Okay? We will assign that to row 2, okay? Row 2, column 2. Yung pinanggalingan. So, it will be stored also at row 2, column 2. So, we have D. Okay? Next, we have next row. Row 3. Okay? Column 1. Row 3. Column 2. Okay? So that will be E and F. Okay? So at row 3, column 1, E will be assigned. At row 3, column 2, F will be assigned. Notice how do we process these elements. We process it by row. Okay? We process it by row. Why? Notice. We have here row 1. So this is our I and this is our J. Okay? So I is 1 and J will be 1 and 2. Okay? I, our row is 2 and our J is 1 and 2. Okay? Followed by, next, I is 3, both are 3, and then our column is 1 and 2. Okay? So, this is row major. Tatapusin mo muna lahat ng elements sa isang row. Okay? So, if you have 2 columns, sa first row, lahat ng columns. Second row, lahat ng columns. Okay? So, in that sense, A is located at R1 sub 1. Okay? R1, 1. Okay? Make use of another ink. And then B is stored at from our source, that is, from our source is 1, that is stored at row 1, column 2. Okay? While C is stored at row 2, column 1. And D is stored at row 2, column 2. While E is stored at, very good, row 3, column 1. And then F is stored at row 3, column 2. Okay. Pansinin. Yeah? This will also be our I and J. Para sila di ba? 1, 1, 1, 1, 1, 2, 1, 2, 2, 1, 2, 1, 2, 2, 2, 2, 3, 1, 3, 1, 3, 2, 3, 2. So that means we could have R sub I sub J will be assigned to B sub I sub J. Okay? B sub I sub J is equal to R sub I sub J. Yan yun. Okay? And then, this statement is a recurring statement or iterated statement. That means umuulit. Okay? Umuulit yung pag-a-assign ng R sub I sub J to B sub I sub J. So that means if there's an iteration, definitely there is a loop. So either you're going to make use of a for loop or you're going to make use of a while loop. Now, let's have first the how do we come up with these two for loops. Okay? Now, we have for each value of I is 1 hanggang 3. So, for I equals 1, okay, equals to 1 up to 3. 3 is our M. So, that's why for I is equal to 1 to M, 1 to M, okay, anong gagawin niya? The value of J varies. Diba? J from 1, naging 2. Tapos, pag naging 2 si I, 1 and 2. So, laging every time we have a value for I, the value of our J will be from 1 to 2. And 2 is the value for our n. So that means, okay, from 1 to n lagi. Yeah? So, this is the value of our j. J is from 1. J is from 1 to 2. 1 to n. Okay? That's it. Okay? Sige. As an exercise for you, no? Simulate this pseudocode. Okay? Simulate this pseudocode using 5 by 3 array. Okay? You provide the elements, the values, the elements of this array named R. Okay? Array named R of size 5 rows and 3 columns. Okay? And then simulate it. Give values for I for each iteration and give values for j for each iteration and what will happen for this assignment statement. Right? Next. If we would have copying by row, so our priority is row. So that will be column major or column wise. As you have noticed, same na same, except for this one. Okay? Since we are pertaining to column major, our priority is column. So that's why we initially have, in our for loop, we started with the J. Okay? And our inner for loop is I. Okay? So that's it. Okay, so let us simulate this given pseudocode. Okay, so we will copy elements of a two-dimensional array by column. Okay, so let's have an example. Let's have an array named R of size m by n. Let's say the array has 3 rows but 2 columns. Okay, just like what we have done in our previous example. So row 1, 2, 3, and columns 1 and 2. And then let us say the elements are we have elements A, B, C, D, E, and F. Okay. So we have E and F. Okay. Now, if you will have a copy by column, that means our priority will be per column. Okay, we will process first all the elements in that column before we go to the next column. So it will process A. Okay, I'm sorry. We will process first row 1, column 1. And then followed by row 2, column 1, followed by row 3, column 1. Okay? And then before we go to the next column. So next column, if we will do that, we have column 2, row 1, column 2, row 2, and column 2, row 3. So notice, for column wise, so this is column wise or column major. Okay? So column major. While for column wise, we process first all the elements per column. If we have the row wise, okay, para makita niyo yung difference, okay? If you will have the row wise or row major, that means we're going to process all the elements per row. Okay, so that means we're going to process first all the elements per row. So row 1, A, row 1, column 1, and row 1, column 2. Before we go to the next row, row 2, column 1, row 2, column 1, and row 2, column 2. Before we go to the next row, row 3, column 1, and row 3, column 2. Okay, so see the difference. There is a difference with its output. Okay, now let us simulate the given Sudoku. Okay, so for column wise, it should have this, it should copy by column. Okay, so we will do that simply assigning an array name R. So I think array name R with size m by n. So as I have mentioned earlier, we have 3 rows and 2 columns. Okay? And then, okay, so simulate natin dito. And then we have array name V, okay, having the same size of its source. So we have 3 rows and 2 columns. Okay? Now, we have we have variables j and I. Okay? Sabi, for j is equal to 1 up to n. Our n is 2. Okay? So j initially 1. And then for I is equal to 1 to m. M is 3. Nagmukha pala yung ano, no? Nagmukha itong 3. So this is 2. N is 2. Okay? Yan. So, I is 1. Okay? So, we have here an assignment statement, R sub I sub j. So, I is 1, j is 1, will be assigned to B I j or B sub 1 sub 1. Okay? That means row 1, column 1. Okay? So, R1, column 1, R, row 1, column 1, we are pertaining to A. So, A will be assigned to B, row 1, column 1. So, we'll have that A. Okay? Next, balik sa for loop. Okay? Sabi niya hanggang 3. So, I will now be incremented. That will become 2. And then, again, we will have this assignment statement. Our I becomes 2. But our J still the same. So, 1 pa rin yan. So, I is 2, J is 1. So, that means we are referring to row 2, okay, row 2, column 1. So, that is C. So, we will assign that to B sub 2, sub 2, sub 1. So, we have C. Next, we have, okay, we'll go back to the for loop. Hanggang maging 3 daw yung value ni I. So, increment natin. Hindi makita. So, gawin natin dito. 3. Okay? Again, we have 3 value ni I. J is still the same 1. So, B sub 3 sub 1. Okay? Is equal to R sub 3 sub 1. So, that means R sub 3, row 3, column 1. Okay? We refer to letter E. So, E will be assigned to B, row 3, column 1. So, we have letter E. Notice that the elements stored by column. All elements in column 1 were stored. Okay? And then next, before it will go to the outer for loop. So, outer for loop, J becomes 2. Then again, go back to the inner for loop for I is equal to 1. So I is 1. And then up to 3. So initially 1. And then we're going to again change the value of I and j. So this time, the value of I, okay, the value of I is 1. Sorry. The value of I is 1, while the value of j is 2. So, row 1, column 2. Row 1, column 2, I am referring to B. So, B will be assigned to B array, row 1, column 2. Very good. Okay? And then next, I will now become 2. And then again, assignment statement. So we have instead of 1, si I magiging 2. Our j still remains with a value of 2. So row 2, column 2, R sub 2, row 2, column 2, we refer to D. So D will be assigned to B sub 2, sub 2. B, row 2, column 2. So we will assign letter D. Okay? Moving on, I becomes 3. Okay? And then, let's assign the value. Let's change the value of I. I becomes 3. But the J is still the same. So we have R sub 3, sub 2. That means R sub row 3, column 2. So we now refer to letter F. So F will be assigned to B, okay? B row 3, column 2. So we have that F. Okay? Hanggang 3 lang daw yung value ng I. So that means tapos na ito. Labas ulit tayo sa outer for loop. Sabi, ang value ni N hanggang, ang value ni J hanggang 2 lang. So, hanggang 2. So, we're done. So, notice the difference if we have it row major and column major. Okay? Next. Just like in a one-dimensional array, we could store the elements of the array in the memory. Okay? There are two representations. We could use, again, row major or we could use column major. Okay? Now, we have two formulas for each. We have one formula for row major and another formula for column major. So, they differ in formula. Okay? Now, let's have this. Consider a 3 by 2 array named M, and each element of the array is one word long. Remember, whenever we store elements of the array, it is always stored sequentially, sunod-sunod, okay? Now, since the size of the array element or the element of the array is one word long, that's why every memory address is one word long, okay? So, every element is stored in a memory address, okay? So, if we will have row major, that means we will prioritize all the elements by row. So, row 1 first, okay? Row 1, column 1 and column 2. Bago siya pupunta sa next row, row 2, column 1, column 2. Bago pupunta sa next row uli, row 3, column 1, column 2. Okay? So, this is how it is stored when we make use of row major. Okay? Now, of course, the formula would be nadagdagan na, no? Instead of before Like for one-dimensional array, we only use start plus k times I minus 1. However, in two-dimensional array, we have two subscripts. That is why we pertains to the ith and jth position. Okay? So, we have this formula, start plus k times. So, this is one term multiplied by the term, okay, by the term um, uh, inside the term or inside this expression is again a compound expression, no? Consisting of I minus 1 multiplied by n plus j minus 1. Okay. Remember, in analyzing mathematical operators, the highest precedence would be inside the parentheses. Okay? So, we first analyze what is inside the parentheses. Okay? And inside these parentheses are a set of expressions. So, we will analyze from left to right. Okay? So, we have two inner expressions. Okay? We have I minus 1 multiplied by n. So, we will analyze this first. Okay? I minus 1 before we multiply it by n. Okay? And then we will subtract 1 from j before we add the result of the expression, the second expression, the third expression of the inner compound statement. Right? So, same pa rin dati, no? With one-dimensional array, when we speak of start, we are referring to the starting address of the first element. While k is the size of each element, that is the number of words occupied by each element. So, that is the size of each element. And then I, that pertains to the desired row number. And then the j is the jth position or the column number of the element desired. And then n is the number of columns in the array. Okay. Ang technique, if we are referring to row major, ang magkasama ay I and n. Okay? So, I minus 1 times n. Why do I say that? Because pagdating sa column major, ito magpapalit. Okay? Instead of using n, we will use m. Okay? And then, uunahin natin yung j bago si I. Okay? Column major, as you have noticed, ganito naman siya. Ang magkasama ay j at saka m. Kanina, sa row major, we have start plus k times the expression of I minus 1 multiplied by n plus j minus 1. Okay? So, this is for the row major. While for the column major, as you have noticed, j minus 1, okay, multiplied by m. So, for row, in, for column, jm. Okay? So, given the example, we have an array of size 3 by 2. So that means row, we have 3 rows and 2 columns. Okay? And we're going to compute for the address of an element wherein the desired element is at row 3, column 2. Now, using row major, we will make use of the formula start plus k times I minus 1 times n plus j minus 1. Okay? So, first, whenever we have a mathematical problem, no word problem, we have to analyze first the given problem. Okay? Sabi, we have here an array of 3 by 2. So, 3 by 2, that means we are referring to 3 rows and 2 columns. Okay? we're going to compute for the address of the element. What element? The desired address or desired element position is at row 3. So this will be our I, and this will be our J. Okay? So I is 3 and J is 2. Now, let us substitute values for each variable. Okay? Now, assuming that the size of the element of each element of the array is 1. That is why we have k is equal to 1. And then for our I is 3, base from here. Okay, so I is 3 and j is 2. While our n is our column. Okay, so this is m by n. Okay, remember, whenever we define the size of a two-dimensional array, that is m by n. Okay, so m pertains to rows and n pertains to column. So we have 3 rows by 2 columns. So that is why the value of n is 2. Okay? And then start is the starting address of the first element of the array. Now, nasaan yung first element of the array? First element of the array is yung merong subscript na 1, row 1, and column 1. So, M11. Okay, so that is the address 0002. Okay, so by applying the formula, we have start plus k multiplied by the term I minus 1 times m plus j minus 1. So, try to substitute first all the variables. So, we have start is 002, and then k is 1. Okay, k is 1. And then for our I is 3, n is 2, and then j is 2. Okay? And then next, we will analyze this expression. Remember, unahin natin nasa loob ng parentheses. Now, inside this parentheses, meron na namang mga parentheses. So, unahin din natin yung nasa inner na parentheses. So, we have 3 minus 2 will be evaluated first. So, 3 minus 2 is 2. Copy lang po natin yan. So, 2 times 2 plus 1 plus 2 minus 1 is 1. Alright. And then, 2 times 2 is 4 plus, copy natin yun, plus 1. So, 4 plus 1 is 5. Tsaka natin siya i-multiply by k. So, 1 times 5 is 5 plus 0002. That turns out to 0007. So, just imagine this, no? We have computed the address of the starting address of the element row 3, column 2 by row major. Okay? So, at row 3, column 2, tama po na ang kanyang starting address ay 0007. Okay. How do you know that the elements are stored by row or in row major? Notice that the elements, okay, are arranged from first row, lahat muna ng first row, okay, tapos tsaka pumunta sa second row, different columns, bago pumunta sa third row. So, this follows a row major representation. Okay? Let's have another example. Okay? Let us say we want to compute for the starting address of the element at row 2, column 1. So, our I is still 2 and our j is 1. Okay? Remember that the first index refers to I and the second index refers to j. Okay? So, still the size of each element is 1, kaya k is equal to 1. And then I, our desired position. So, row 2 and j is 1, column 1. And then n is the size of the array. Remember, the size of the array is 3 rows by 2 columns. So, n is 2. Okay? And then the starting address of the first element is at 0002. Okay? So, again, let us just substitute all the variables with its corresponding value. So start is 0, 0, 2, k is equal to 1, I is equal to 2, j is equal to 1, and n is equal to 2. Okay? And then, evaluate natin inner muna na mga parentheses or inner expressions. Okay? So, we have 2 minus 1. Kaya yon 2 minus 1 naging 1. Okay? Copy mo lang yung iba. 1 minus 1 is 0. Okay? So, 1 times 2 is 2 plus 0. Naging 2 times 1 is 2. And then add it to 0, 0, 2. We make it 0, 0, 0, 4. Ayan. Okay? So, tama. Di ba? Element at row 2, column 1 is stored at address 0, 0, 0, 4. Okay? Now, the technique is, first, of course, we have to analyze the given problem. And then, kapag tama yung iyong mga analysis, no, yung mga corresponding values for each variables, definitely, more or less, tama yung magiging computation mo. However, kailangan mo ring i-consider at tandaan yung level of, or yung hierarchy of precedence, that yung inner parenthesis muna o yung mga parenthesis muna ang una-evaluate bago ang multiplication, bago ang addition and subtraction. Okay? Kaya po ganyan natin siya in-evaluate. Now, most of the students, kaya naman nagkakamali sa pagko-compute because na-excite silang i-multiply ka agad, no? Like, in this expression, minsan kasi ginagawa ng mga bata, no, ng ibang estudyante, yung 1, minimultiply ka agad dito sa expression dito. Okay? Remember, this is a compound statement. So, you have to generate first the value of this compound expression. Okay? You have to compute first for this compound expression before you multiply it with k. Okay? So, ibahin naman natin. What if same array, row 3, that has 3 rows and 2 columns? So, we have m by n. Okay? Kaya lang, this time, the element, each element has a size of 2 words long. So, 2 words long, yan po yung value ng k natin. Kaya k is equal to 2. Okay? We will compute for the starting address of the element. Again, 3, 2. So, at row 3, column 2. So, we refer to I for the first subscript and the second subscript for the j. Okay? So, we want to know the address at row 3, column 2. Okay? So, that's the value of I and j respectively. And then the n is, titingin ka dun sa size ng array. So, n is equal to 2. And then the starting address, kung nasaan nakalocate yung first element. So, starting address of the first element is at 0002. So, ganun pa rin. No? Using the formula, start plus k times the expression of I minus 1 times n plus the expression of j minus 1. So, substitute all the values. K is equal to 2, start is equal to 002, I is equal to 3, n is equal to 2, and j is equal to 2. And then, analyze natin, lahat muna nasa loob ng parentheses. So, 3 minus 1 is 2, okay? Multiplied by 2, plus 2 minus 1, 2 minus 1 is 1. So, 2 times 2 is 4, bago mo i-add kay 1. Okay? Ayan, merong iba dyan nagkakamali. Ina-add muna. So, parang yung iba, kunwari ginawa, 2 plus 1, naging 3 times 2. So, may iba talaga yung result nun. So, first, multiply mo muna bago ka mag-add. Okay? So, we have 4 plus 1. So, 4 plus 1 is 5. Multiply by the value of k. So, multiply by 2. That will be 10. So, plus 0002. That will be 00012. So, as you have noticed, yung kaninang example natin, Same example, right? We want to know the starting address of the element R, element M at row 3, column 2. However, the difference is yung size ng bawat isang element. Previously, the size of the element is only 1. Pero ngayon, sa ating ngayong example, the size of each element is 2. So, kung kanina, nasa 0007 yung element na to, syempre may iba yon because ang naging size ng bawat element is now 2. Okay? Next. Let us say, same pa rin, no? The size of each element is 2. Same pa rin siya. Pero ang gusto nating hanapin is element 2, 1. Element at row 2, column 1. Okay? So, I is 2. Ito yung I. Ito naman yung J. Okay? Ayan. And the rest are all the same. So, all we have to do is to substitute all the values. Okay? And then analyze it. So, 2 minus 1 muna, kaya 1. Okay? Multiplied by 2. And then, 1 minus 1 is 0. So, 1 times 2, 2 plus 0. So, 2 plus 0 is 2. Multiplied by 2, kaya naging 4. Plus 0002, so that would be 0006. Tama. Diba? Nakuha ba? O sige, another example. let's have another example. Let us have a 3 by 2 array. Again, it is named M, and each element is 2 words long. So we have to compute for the address of the element at row 3, column 1. So let's provide the value for each variables. It says here it is each element is 2 words long, therefore k is equal to 2. And then for our I, we want to compute for the address of the element at row 3, column 1. So the I is 3, value of I is 3, and value of j is 1. And then, what's the value of n? Titingnan natin yung size ng array. So, m by n. Okay? So, n is 2. Alright. And then, the start is 0002. Now, since the manner of storing these elements are using row major, because we have here row 1 first, yeah? Then row 2, then row 3. Okay? So that's the row major. So using the formula for row major, we will have start plus k multiplied by the term I minus 1 times n, so in, plus j minus 1. Okay. So, the value of the starting address of the element is at 0, 0, 0, 2. Medyo malabo, no? Plus our k is 2. And then, inside the parentheses, we have I. I is 3 minus 1 multiplied by n. N is 2. Plus j is 1 minus 1. Alright. So we have 0, 0, 0, 2 plus 2 times the term 3 minus 1, that is 2, okay, times 2 plus 1 minus 1 is 0. Okay, so next 0, 0, 0, 2 plus 2 multiplied by the term. We have 2 times 2 is 4 plus 1 minus 1, so 0, so plus 0. Okay? So, we then add 4 plus 0 is 4. Bago natin siya i-multiply with 2 plus 0, 0, 0, 2. So, we have 0, 0, 0, 2 plus 2 times 4 is 8. And then we have 0, 0, 2 plus 8 is 0, 0, 1, 0. Okay? So, check natin, no? Tama ba nakastore yung element at row 3, column 1 sa address 0, 0, 0, 10? Okay. Tama. Okay? Alright. What if we're going to store the elements by column? Okay, so you make use of the column major. Okay, in a column major, definitely the elements will be stored by column. So our priority is per column. So as you have noticed, we have here column 1, and then row 1, row 2, row 3. Bago pupunta sa row 2, column 1, 2, 3. So that is how these elements, that is how the row major and the column major differs. Okay? So, even in the formula, so ng kanina na diniscuss ko, no? The formula would not be the same. Okay? So, magkaiba siya. Okay? Instead of using I minus 1, we make use of j minus 1 multiplied by m. Okay? But the start is the starting address of the first element. K is the size of each element. I is the row number of the element desired, and j is the column number of the element desired, and m is the number of row in the array. Okay, so that is the in terms of the size of the array. Okay, so let's have an example. Let's compute a 3 by 2 array and compute for the starting address of the element at row 3, column 1 using column major. Okay, so using the formula for the column major, we have the formula. Okay, now let us substitute all the values. Since wala ditong nilagay how many words long, so by default, it is 1 word long. Okay, kaya k is equal to 1. And then, what's the value of I and j? Since we are looking for, or we're going to compute for the element at row 3, column 1, so still, our I is the first index, and the second index will be our j. Okay, so still, I is 3 and j is 1. And then, what's the value of m? M is, that will depend on the size of the array. Remember, the size of the array is m by n. So, m is 3 because we have 3 rows. Okay, so we have m. And then, the value of the start is 0002 because the starting address of the first element is at 0002. Okay, so, substituting the value 0002 plus the value of k is 1, and then j is 1, okay, m is 3, I is 3. And then let's follow the formula. 1 minus 1 is 0. Okay, copy lang natin yung 3. And then 3 minus 1 is 2. And then 0 times 3 is 0 plus 2. So that will be 2 multiplied by 1. And that will be 1. That will be 2. So, 2 plus 0002, that will yield to 0004. So, tama. Okay? So, element at row 3, column 1 using column major is stored at address 0004. Okay? Let's have another example. What if we're going to compute for the starting address of the element at row 2, column 2. Okay? So, by default, again, walang sinabi kung anong size of the element. So, k is equal to 1. And then, what's the value of our I? I is dun sa ating desired na co-compute, no? Desired row. So, we have I is 2 and j is 2. So, parehas na 2. And then, m is 3. Okay? And then, the starting address of the first element is at address 0002. Okay? So, substituting again all the values of the variables. So, start is 002, k is 1, j is 2, m is 3, and I is 2. And then, following the formula, evaluating the expression, so unahin natin nasa loob ng parentheses. So, 2 minus 1 is 1. Okay? 2 minus 1 is 1 also. Okay? Before we multiply it with 3, so 1 times 3 is 3 plus 1. Okay? Saan nakuha yung 1? Doon sa 2 minus 1. So, 3 plus 1 is 4. Tsaka natin multiply by 1, so 4. And then, tsaka natin siya i-add with 0002, and that will result to 0006. Okay? So, we have stored, we compute for the address of the elements at row 2, column 2. Okay? So, it is stored at address 0006. Okay. Next. Now, let us say we're going to compute for an element or elements, no? Wherein still the size of the array is 3 by 2. And then the size of each element of the array is 2 words long. So, our k will now be 2. Okay? The size of the array is m by n. So, m is 3. Okay? And the starting address of the first element is at address 002. So start is 002. And then what's the value of I and j? So we're going to compute for the starting element, starting address of the element r, m sub 3 sub 1. So our I is 3 and our j is 1. So ito po yun. So substituting all the values, we have k is 2, okay? And our I is 3, tama? I is 3. J is 1, ayan. M is 3, and then start is 0002, okay? Again, we're going to evaluate. Unahin natin nasa loob ng parentheses. So, we first evaluate 1 minus 1, so that will be 0, okay? And then we have 3 minus 1, that will be 2, okay? Next, 0 times 2, that will be 0, plus we have 2, okay? So, 0 plus 2, that will be 2, multiplied by 2, that will be 4, okay? And then we're going to add with the starting address of the first element, 0002. So, 002 plus 4 is 0006. Okay, so tama ba? Yun. So, element m sub 3 sub 1 is stored at address 0006. Okay? Now, notice that each element is 2 words long. Okay? 2 memory addresses because the size of the array or the element of the array is 2 words long. Okay? So, what if we're going to compute for row 2, column 2? So, the value of I is 2 and the value of j is 2. Still, same problem, no? The size of each element is 2 words long. Therefore, k is equal to 2. K is equal to 2. Oh, masyadong madilim. Okay. So, k is equal to 2. And then, we have I is 2 and j is 2. Okay? M is 3 because, sabi nga natin kanina, based dun sa given natin, the size of the array is m by n. So, that is, the array size is 3 by 2. Kaya, m is 3. And then, the value of start is the starting address of the first element that is located at address 002. Okay? So, applying the formula, start, substitute lang natin. So, start is 002. And then, the value of k is 2. And then, the value of j is 2 also. So, we will simply substitute values, okay? So, j is 2, while our our I is 2, okay? And our m is 3. Okay? So, after substituting the values, we're going to compute based on its expression. Okay? So, we have here 2 minus 1. Unahin muna natin nasa loob ng parentheses. This one. Okay? So, 2 minus 1, that is 1. Okay? And then, we have 2 minus 1. Again, it is 1. So, yung 3, copied lang, based from here. Okay? And then, yung 2, yung k. And then, yung starting address of the first element, kinapi lang natin. Okay? And then, next, we will first multiply 1 by 3. This one. Okay? So, 1 times 3, that is 3, plus 1. Okay? So, 3 plus 1 is 4, multiplied by 2. So, 2 times 4 is 8. Plus, our starting address of the first element is 0002 plus 8 is 00010. Okay? So, tama. Okay? Understand? Understood? Alright. Good. So, for your exercise, for your activity, you're going to compute for the following addresses. Okay? So, uh, consider an array of 7 rows and 5 columns. 7 rows and 5 columns. So 7 rows and 5 columns. So we have M by N. How many rows? We have 7 rows and N, how many columns? 5. So the size of the array is 7 by 5. Okay? That is named Krishna. So, iba naman yung pangalan ng array. And each element is 3 words long. Okay? So, 3 words long, that means the value of our K is equal to 3. Very good. And then you're going to compute for the starting address of these elements. Okay? So, what's the starting address of the element? Okay, Krishna 7-3. So, I is 7 and J is 3. Okay? Using column major representation. Okay? So, follow the formula for column major. Formula, again, we have start plus K multiply by the term. Okay, pag column major, mauna ang J. So, J minus 1 times N plus I minus 1. Okay. And then, starting address of the first element is 60000. Therefore, value of start is 6000. Okay? So, I leave that to you. Compute it on your own, okay, for your practice. Okay, so do A and B. Okay? So, if you have questions, just send me a message or reach me through my messenger. Okay? So, that's it for today. Thank you and God bless. Stay safe.